Hello everyone, we are Group 1 and we present before you a machine learning project which is named as Detection of Diseases in Plants. I am Shagun and my rest team members are Shamika and Adheik. The, the briefing about this project is as follows. The code that is given below basically demonstrates a supervised machine learning model that is used to detect and classify plant diseases into their respective categories. The dataset that is used throughout the project is a plant disease dataset that was obtained from an open source platform which was contributed by Samir Bhattrai. The plant diseases are categorized into the following 38 subcategories, and the model here that we've used is able to detect and classify the diseases accurately. In order to evolve the model that we've used here, we can further try experimenting with different inbuilt models or try creating our own models, which can be as EfficientNet, InceptionNet, or any CNN model that we think can be compatible and can produce a proper accuracy. The model that we've built is a model with a baseline. The baseline model that we built is a CNN model, and because we didn't find a proper accuracy, we further tried to improve the accuracy by using EfficientNet, a B0 model. And this is a transfer learning side of machine learning wherein we used EfficientNet, and after training a model, we got an accuracy of 81%. The future scope of this model is that in future, if we go in depth, the model will be able to uh, detect plants with dual diseases, that is plants that has two diseases together, and then also subclassify the diseases into their further subcategories, which may be a subcategory in the already existing category.
Is to detect various diseases in plants. So here we have initially imported our basic libraries like NumPy, Pandas, and Matplotlib. Further, as our model is using TensorFlow, so importing the TensorFlow, and from that we are importing image data generator to generate the images, and further to convert image to array for training and loading images. Here we are using a pre-trained model, EfficientNet B0, as we are using a transfer learning technique to finally train a model. Here, as you can see, there are 38. There are various classes of the plant disease data set. You can see these are 38 classes. Import the pre-trained model. We have imported pre-processed input, and for predictions we have used imported decode prediction. Here we are loading the data set, training data set and validation data set, and training the models. In the training data set, we have 70,000 images belonging to 38 classes and 17,000 images belonging to 38 classes in validation data set. After that, we are importing. After that, you can see what images are classified or passed to the model. Building the model. Here we are importing transfer learning technique and building a model. To pass the data set, we have to flatten the base model, and then the dense function has 38 units, as we have 38 classes in the data set. And for activation function, we are using softmax. To avoid, initially in the convolutional neural network model, we face the problem with overfitting. So to avoid overfitting, we are using early stopping. For the matrix for the model compile is accuracy, and for early stopping we are using the validation accuracy. As soon as the validation accuracy decreases, the model will stop training, and the epochs would stop. You can see this here, as though we have 50 epochs, the training stops on 12th epoch as the validation accuracy decreases. So From this, we have plotted validation accuracy and training accuracy. Further, we are plotting validation loss and training loss. So the best model is saved to our data set and further it is loaded for prediction.
Part where we're predicting the image and we're going to classify them. So we are using a prediction function here. So basically we cannot use the any image as it is because of the dimensions of the image. We need it to be specific so that our prediction function can predict the image. So we're going to be extending the dimensions of the image to get it into a specific target size. And then we'll be using the argmax function to predict the most optimal class. And then the image, wherever, like if example, taking an image from Google, we'll be checking it against the images in the path, which is stored in our local folder, and we'll be predicting it against that and predicting the disease of the plant. You can see below, we have already done one prediction case and it has written the correct value. Like we can see below that we have predicted tomato spider mites and it has correctly returned the value that it's two spotted spider mite. So in conclusion to our project, which is the detection of plant diseases, we first went with using the sequential model, which is CNN, and gave us an accuracy of around 65%. Then we went on to using built pre-trained models for better accuracy rates. So we first went with VGG19 and got an accuracy rate of 71%. And to get a better accuracy, we went with the efficient model and got an accuracy rate of around 81%.